All right, guys. I know this assignment is really dragging out. I think these problems should go a lot quicker than the previous part of this homework assignment. Um, so let's give this one a go. So positive variables p and c change with respect to time. So that means p and c are dependent on time. They're dependent. I forgot how to spell dependent, so I'm not going to write that. They're dependent on time. The relationship between p and c is given by the equation here. At the instant dp dt is equal to 41 and c is equal to 15, what is dc dt? So we're going to take the derivative of this right here. So let's start on the left side. I take the derivative of p squared. That's going to be 2p, but because p is dependent, I have to multiply by p prime. That's going to be equal to, I'll take the derivative of this side, so it's going to be 3. Then we're going to have 20 minus c, and that's going to be squared. Now I have to go in and take the derivative of the inside. The derivative of the inside is going to be negative 1. So negative 1, but then I have to times by the derivative of c since it's dependent. So I'm just going to call this negative. So times by negative c prime. And c prime is what we're trying to solve for. So we can also plug in some values. So p prime is 41. C is equal to 15. So I can also solve for p here. So I can plug in c. So let's do that also. So I get p squared is equal to 20 minus 15 cubed. So p squared is going to be equal to 5 to the third. Oh my gosh, why? And then p is going to be equal to the square root 5 to the third. Isn't that like 125? I think. Okay, sure. I guess. I don't like where this is going. But we can plug this in. So we have 2 times by square root of 125. 125 doesn't have a square root, does it? There's no way. Yeah, it doesn't, no. Times by p prime, which is 41, equal to 3 times by 5 squared times by negative c prime. And so I can simplify that right there. So 125, the square root, so 125, so square root of 125 is the same thing as 5 times by 25, and the square root of 25 is 5, so 5 root 5. So this becomes 2 times by 5 root 5 times by 41 equal to negative 75 c prime. Okay, and then let's simplify this right here. We have 41 times, so this, what in the world are these numbers? So we have 41 times by 10, so that's going to be 410 square root of 5 equal to negative 75 c prime. So c prime is going to be equal to 410 square root of 5 over negative 75. I'm leaning towards D because those are what these numbers add up. I have 410 and 75. I don't think that's a ratio of 3 halves. It's definitely not a ratio of 2/3 since 410 is larger than that. So I'm going to say D. And then I'm honestly just going to call it, I'm pretty sure it's D, so I think that's good. All right, an isosceles right triangle with legs S has an area of area equal to 1/2 s squared. So isosceles right triangle, so basically a 45, 45, 90 triangle is basically what it's referring to. If it's isosceles right triangle, so isosceles right triangle meaning that the legs are the same. Yeah, and it's a right triangle, so yeah, this is a 45, 45. So we'll just call this right here S and S. So area is going to be equal to 1/2 s squared. Yeah. At the instant that s is equal to the square root of 32 centimeters, the area of the triangle is increasing. So area of the triangle is increasing. We'll say A prime is equal to 12 square centimeters per second. So centimeters squared per second. At what rate is the hypotenuse of the triangle increasing? So the hypotenuse. So this is h. So the hypotenuse is increasing. We're trying to find h prime. Okay. Trying to maybe make sure that I have everything accounted for in terms of what is dependent. At the instant, the s, the area. Yeah, so the sides have to be increasing if the hypotenuse is increasing. So, yeah. So, let's take the derivative of this right here. So, we'll say a prime is equal to, when I bring down the 2, that just becomes 2 over 2, which becomes 1. So, then we'll have s to the first power, but then sorry, I'm a little immature. Because that's just funny right there. A prime is equal to s times, that was not intentional, I'm sorry. A prime times by s prime, yeah. Okay, let's see. So a prime, we're trying to find, no, a prime is 12. So I know that that's going to be 12 is equal to square root of 32 times by s prime. So I can say that s prime is equal to 12 over square root of 32. Although that's not what we're trying to find. We're trying to find h prime. So that means what I'm going to do now is I'm going to take the Pythagorean theorem. So s squared plus s squared is going to be equal to h squared. So that's going to be, yeah, that's going to be equal to 2s squared is equal to h squared. So I'll take the derivative of that. So the derivative of that is going to be 4s times by s prime equal to 2h times by h prime. So 4 times by s, do I know what s is? Yep, so square root of 32 times by s prime, which was 12 over square root of 32. And then equal to 2 times by h. So if s is equal to square root of 32, so I can actually plug this in right here to find h. So we'll say this right here. We're going to say 2 times by square root of 32 squared. It's going to be equal to h squared. So that's going to be 64 is equal to h squared. So that means that h is going to be equal to 8. So h is going to be equal to 8. So 2 times by 8 times by h prime. Okay, so the good thing here is that those cancel. So we get 4 times by 12, which is going to be equal to 48. It's going to be equal to 16 times by h prime, which means h prime is going to be equal to 3. Okay, that one was a lot more work than I thought it was going to be, but all right, for 3, a cube with edges of length x centimeters has volume v of x is equal to x to the third cubic centimeters. The volume is increasing at a constant rate of 40 cubic centimeters per minute. At the instant when x is 2, the rate of change of x in centimeters per what is? So we're trying to find x prime. So I'm going to take the derivative of this right here. So I'm going to say v prime is going to be equal to 3x squared times by x prime. V prime is 40 equal to 3 times by, what is x? X is equal to 2. 2 squared times by x prime. So 40 is equal to 12x prime. So x prime is going to be equal to 40 over 12, which is going to be equal to 20 over 6, which is going to be equal to 10 over 3. Okay? All right, this one looks, I think I've done this one before. It looks familiar. So a region is bounded by 2 concentric circles as shown by the shaded region in the figure above. The radius of the outer circle, r, is increasing, so I'm going to say r prime is equal to 2. And the radius of the inner circle is decreasing, so r prime is equal to -1. Okay, what is the rate of change in square inches per second? So that's going to be like an a prime of the area of the region. So what's what region? The shaded region. So I think it's this region right here is what we're trying to find the rate of change of. So we need to find an equation for that area. So area of our region, region is bounded by 2 circles shown here. So the area of that region is going to be equal to the area of the outer circle. So the area of the outer circle, which is going to be pi times by r squared, big R squared. So pi r squared minus pi times little r squared. Yeah. So when I take the derivative of this equation, I get a prime is equal to 2 pi r times by r prime minus 2 pi and then r times by r prime. So a prime is going to be equal to 2 pi, so that's going to be times by 4, that's given to us, times by r prime, big R prime, which is 2, minus 2 pi times by little r, and little r is 3, times by little r prime, which is -1. So that's going to be equal to, that's going to be 16 pi plus 6 pi. So is that going to be equal to 22 pi? I think it is. There you go. And then the last question right here. A spherical snowball is melting in such a way that it maintains its shape. So it's still going to maintain as a sphere. The snowball is decreasing in volume at a constant rate. So I'm going to say V prime is equal to -8. At what rate in centimeters per hour is the radius? So we're trying to find r prime. A snowball decreasing at the instant when r is equal to 10 centimeters. So they give us a volume. So let's take the derivative of this. So we know that volume is dependent. So V prime is going to be equal to, now the only variable here is r. All of this is constant. So I'm going to use the power rule. So I'm going to bring down the 3. And then pi times by r squared, but then I'm going to multiply by r prime. So then those just cancel right there. So I'm going to say that v prime, which is -8, so -8 is going to be equal to 4 pi times by r, which we're saying is 10, times by r prime. So -8 is going to be equal to, is that going to be 400 pi times by r prime? So r prime is going to be equal to, so it is decreasing, so what is it decreasing at, which is why, so we have -8 over 400 pi, so I think it's got to be A or B since pi is in the denominator. What is 400 divided by 8? Yeah, so it's going to be A. So 8 over 400 reduces to 1 over 50. So, okay, there you go. That's implicit differentiation. It's definitely a challenging subject. A lot of problem solving, but hopefully this video helps.